Hi, my name is Leandro Facchinetti, and let's write some code together, shall we? What we have on the menu today is the Fourier transform. We are still working on that. It is going to be part of our library for developing JS effects. And we want to see what's going on. We want to be able to see the Fourier transform. And to plot the results of the Fourier transform, we hit this wall where we don't really have a function that is capable of plotting the kind of data structure that we have going on. So we are either going to create some transformations between data structures in our library, or we are going to change the plotting function itself, right? So let me first see again what I have here in terms of the plotting function, because I forget. So I have this line graph function that receives some chunk of data, and that chunk of data is represented as a circular buffer. And then I receive the coordinates of where I want to plot this line graph in the graphical user interface and the thickness of the line. And the issue is that sometimes the data is not a circular buffer, so I should be using some other kind of data structure instead when I'm graphing. In particular, when I'm doing the Fourier transform, I'm not using circular buffers, I'm using arrays, and then I'm not able to use the line graph function with an array. So there are two options. We can change this to not use circular buffers, or we can convert from arrays into circular buffers or vice versa. I think that maybe the best is for this to be a function over arrays. And then we have a function that transforms from circular buffer into array. I think that that is the best option because we do have some data structures that are not arrays. But, and I mean, when I say data structures that are not arrays, I mean things like circular buffers where you have been pushing samples. So maybe you are doing some sort of oscilloscope kind of thing. So you're collecting samples to display. But there are data structures that are not circular buffers, like the arrays that come out of the Fourier transform. And if we have to choose between the two, I think that the array is the more general data structure and the circular buffer is kind of a particular version of that. So I think that the line graph should work over this general version. But moreover, to convert between a circular buffer into an array or vice versa is going to be somewhat expensive in terms of CPU. And the line graph thing is only going to be called in the GFX block. It is one of the functions. It's one of the functions that only makes sense in the GFX block, and the GFX block is run a lot less often than the init block, or not the init block, the sample block. So it means that we are going to run this transformation from circular buffer into arrays a lot less often to be able to use the line graph function. And that's why I think that this is the best option. So we are going to start by changing the line graph function, in particular the data. It is going to be an array. And while we are here, we are also going to change some other things about the line graph function that I don't like. I think that we should have a range, and then the data will be plotted in this range. This will make the function more generic, I think. So I don't know where to start, actually. I can start with the line graph, or I can start with the data structure conversion. I think I'm going to start with the line graph because it's more visual. It's more fun that way. So let me review everywhere where I'm using this so I will know what I need to change in terms of places where this is being used. So it seems like it's only being used in a single location. Excellent. This location is the place where we do sort of an oscilloscope kind of effect. In fact, let me show you this in action. I'm going to do the usual drill of removing all the outputs, muting, and then decreasing the volume, so we are absolutely sure that we are not going to hear the effect. Then I will drop my demonstration effect, and I will go to this page. And I forget why we have a delay length situation. Oh, so this is actually a delay effect. It is actually affecting the audio as well as showing this. And for us to see something happening, let me change this input to be my microphone. And now you can see as I speak, oh, it doesn't get bigger. As I speak, you can see the line graph updating here. That's great. Let's make it bigger. I don't need a padding on the top or on the bottom. I think I will have a padding though. Yeah, times GFX X retina. And I will grant a size for this screen that is going to be something like right now, it is a rather small screen that we have here. So let's maybe have something like 380 by 280, and that, given the paddings on the top and on the bottom, gives us 400 by 300. And we have to multiply this retina, which is not spelled correctly. We have to do this multiplication in these two locations as well. And then this line actually became too long for me to be happy, so I'm gonna wrap it. And then I'm going to do this adjustment so that everything lines up nicely. Great. Now I am going to reload the effect. And let's go to the circular buffer page. And here it is. It is bigger, and we can see the waveform as it's coming. So there is this bug here and the notion that we are using circular buffers as the input. So a couple things to fix about this, right? Well, I guess I said that I was gonna start with the line graph, but if I want to change this data structure, I might as well start with that. That is going to be a significant change. So yeah, let's start with this. What I want is to have an auxiliary function that will convert from my delay line, which is a circular buffer, into an array. And then the line graphs function is gonna work with arrays. So I think that this actually belongs further up in the project where I have my data structures. And I think I will have a circular buffer function. So it's a function in the circular buffer class or object, and it's going to produce an array. I'll call this circular buffer to array. And you may note that I am passing as argument the circular buffer that I want to convert, but I'm also passing as argument and the array. So I have to produce an array, but I cannot return an array because an array is a data structure, it's a piece of memory, so it needs to be allocated already. In other words, I am passing this argument, but it's actually an output to the function. Right, so let's maybe start with the use of this to see what it will look like. And I think it belongs next to the delay line. Or maybe I'm going to have some sort of unit test for this. So maybe let's go further up next to the circular buffer, and let's define a circular buffer dot array, which is going to be the result of converging this, and I'm going to allocate an array of 3 positions. It needs to match the size of the circular buffer, right? And then I'm going to call this function with my circular buffer as well as my array. And then maybe I can move this whole thing up because well, I think I'm going to do it like this, because I can do the whole setup for testing the circular buffer, and then I can test the circular buffer, all the functions in the circular buffer in one pass. And that's more or less what I'm doing here. I'm testing stuff about the index in the circular buffer. I'm testing stuff about the getter in the circular buffer. So I'm going to just add more tests here for the toArray part of the circular buffer. But I need to make sure that I allocate memory before I start using it, and I need to make sure that I called toArray to convert the circular buffer into an array. So now when this line is over and the tests actually start, everything else was just the setup for the tests, so we can start writing some tests. So I have my circular buffer array, which is a kind of array, so of course, it's not implemented yet, but it will be a kind of array. So let's look at the array functions, and we want to get a hold of the data in the array. And we want, so let's see the data that we put into the circular buffer. It only has 3 positions. So I will write this at this point here, and then I'm going to remove it. So the circular buffer has 3 positions, and the positions start with zeros. So then we put, I think it goes like this. I think we put 110 in there, then we put 111, and then 112, and then we wrap back and put 113. Arya is here. Hey Arya, great to have you. Just saying hi before work. Good for you, my man. Good for you. I mean, good for you that you are saying that you cannot be here because you have work to do. So this is the position of the pointer right now. I actually want to double check if what? Arya says, I don't know if YouTube is glitching or this stream actually has 4.5 thousand views. What is that about? Did I suddenly become popular? I see 4 concurrent viewers and I don't see any spikes here on the analytics. But, you know, if 4.5 thousand people want to see me coding, then I'll take it. I don't mind. You are all welcome on this stream. Go figure. Right, so maybe I was featured on Reddit or something. So one thing that I want to double check, because I forget when I implemented this, is if I update the pointer after or before I update. Okay, I'll see the screenshot. So I want to remember if I update the pointer after or before I put some data in there. So let's go to the circular buffer push method, and then we'll see. So I take the index and then I put my sample in the index position after updating the index. So the index points at the most recent piece of data. And because our most recent piece of data is 113, the pointer is right here. The pointer is pointing at the latest piece of data in that is actually valid in the data structure. So it goes like this. So this is the result of running these three operations. This is what the circular buffer looks like at the end. And naturally, what we want is for the array to look like, so this is the circular buffer, okay? And what we want is for the resulting array, when I call this toArray situation, is I want to have this. And then there is no notion of pointer, so I don't have to do this second line. Let's check the good old mail. Yeah, I just flashed my inbox on my stream. Isn't that something? That's not a smart idea, is it? Yeah, I guess I can show this one. Hello, Mr. Adonis. What the hell? But I don't think you sent the screenshot via email, did you, Arya? Okay, so let's, with this knowledge, let's write the test for this. So the data at position 0 should be equal to 111. If it's not equal to, then we are going to throw an error, or we are going to signal error. And then it goes like this. Alrighty. Oh, you did send it by email? I didn't receive it. Not yet, anyway. Let's not flash our inbox on the stream again. Okay. Good face. 4,000 views. I'm happy. My YouTube channel is going well, it seems. Not going to complain. I always knew that writing an obscure programming language and obscure real-time audio effects for a kind of obscure DAW, I always knew that that was the recipe for success here on this platform. I always knew. Right, so the tests are here. Let's actually write some implementation for this, right? I will cut and paste this over here on the implementation because it will help me reason about the indices. It's very easy to make a off by one mistake here in this situation because we have so many numbers to worry about. And I'm pretty sure that I will need to get a hold of this stuff. So this is just me deconstructing the circular buffer to get a hold of the current index. So in this case, the index is equal to 0. And the signal is equal to this. And the signal happens to be an array. Am I right? Yes. So the signal happens to be an array, and that's cool. And then we have the signal size, which in this case, we know to be 3. There are 3 positions in the array. And the signal data is actually this array, so I don't have to actually write it down again. And Arya says, all right, I'm heading to work, but it was fun distracting you for a while. We'll leave the stream for the algorithm. Alrighty. So the way that we are going to implement this is actually kind of a smart thing because, well, there is the silly thing we could do. We could loop and copy the data one by one item at a time. And that's silly because it's a loop and super slow. But Reaper comes with this function called memcopy. And it's called memcpy, of course, provides the ability to quickly, we'll see about this quickly promise, but they're saying it's quick, so I'll use this. We'll see if the performance of our plugins are going to keep up. But it will quickly copy regions of the local memory buffer. If the buffers overlap or either crosses a boundary, blah, 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 the results may be undefined. Actually, this is something that we will have to worry about at some point. We'll have to worry about the memory alignment. But I'm pretending that this is not an issue right now. And if you're interested, the alignment means that some functions like the FFT that comes with REAPER, and not the one that we are implementing, but the FFT that comes with REAPER and memcopy and a few others, convolution, they have this limitation that the chunk of memory that you're using must not cross this boundary. So you cannot be at this position and you cannot cross any multiple of this position. So we will have to have some sort of memory allocator that is aware of the alignment. And you can ask the memory allocator, if you know that you're going to use an array for the purpose of passing it for convolution, for instance, or for copying memory, you need to tell the allocator, oh, please make sure that you allocate some piece of memory that is not going to use memory in this boundary. That is kind of a tricky thing to do, and I am not going to worry about it right now. So hopefully in my tests, I'm not crossing any of these boundaries. Let me double check real quick, because we have a circular buffer of size 3 here. So that's not going to cross any boundaries because it's nowhere near this much. But we do have another circular buffer, which is a delay line of 1 second. And 1 second is 48,000 samples. So it doesn't cross the boundary either, I don't think. So that should be fine. But if we had a circular buffer of 2 seconds, it would cross one of these boundaries. And then we would be clever about that. And that will be annoying. But it's a problem for future us. So we do have all this information over here. And one thing that I could do, but I won't, is to check that you are passing me a circular buffer with the same size as the array. I could check that, but checking that will make things slower ever so slightly. So I'm not going to check it. I'm just going to pretend that you are a smart guy and you passed the right parameters. All right, so let me find the documentation for this again. So this is how you call this. And we are going to have to call this twice, right? Because there is a section that is from us up to the beginning. Or actually, there is a section that goes from after us to the end. And we want to copy that first. And then we want to copy... I'm not well today. Then we want to copy stuff from where we are to the beginning. So we'll have to do some math now and think about indices, and we'll make off by one mistakes. It will be a lot of fun. So where is the source and the destination of this? Besides having this, I need to declare these variables as local variables. So let me get ahead of the issue and declare these variables here. there, but I will also want, oh, now that I see this, you know what? I think I want to have like signal and then signal.size and signal.data. I feel like renaming all of this. I will put some to do here. Okay, so we'll need to do 2 of these mem copies. And I will do the renaming at least for this one. But there are other functions like the one above that also have these local variables with the wrong name. It's not following my naming convention. All right. So what is the source of this data? And what is the destination? Well, I need to get a hold of the data of the array as well. So I'll also have an array data. Like that. And then I will need to put the source. Well, the destination is going to be the array data at some index, and the source is going to be the signal data at some position. And the length is going to be some number as well. So now all we got to do is compute these indices. Let's first reason about the situation that we have here, which happens to be an edge case, which is sort of cool. So is there any situation where we don't need to copy stuff from after us? Actually, yes, there is. So let's write this down so we can reason about it. So suppose that I am in a situation like this. In other words, what I expect to come out is exactly that. So I don't have to copy anything from after me. And this is the first copy I'm doing, the copy from after me. So I have to check if my index, so in this case, the index would be 2 and the signal size would still be 3. So I have to check if my index is less than the signal size minus 1, then I'm going to do the copy. Otherwise, I'm going to skip this copy. And now this is the converse. I'm in the beginning. So do I need to copy anything from before me? I actually do, because this copy from before me includes myself. So this is something that is always going to happen. This one is conditional. This one is not conditional. It is always going to happen. Now let's work out the indices for this copying. I know that the index in this situation is 0, and I want to copy from, well, let's start with the destination. The destination is the array, and I want this destination to be 0, the data at 0. Oh, I shouldn't be doing this. I should be doing that because I need to give it an address. I don't want to give the data at that address. I want to give it the address itself. So it's the array data plus 0, which is this position here. I will have an array indices situation going here. Becomes more visual this way. So I want to start copying at array 0 always, and I want to copy the signal data at index plus 1. So in this situation it is, I guess in this situation it is 0 plus 1, which is this guy, position 1. So it is plus index plus 1. And then what is the length of this? Well, it is the signal size minus something that has to do with the index. Let's think about this case, for instance. I want to copy 2 elements. That's because I'm in position 0. So the size of the array is 3. So I guess it goes like this. Let me double check. So the signal size is 3. My position is 0. So I end up with the number 2. I want to copy 2 values. Is that right? Yes, that is right. Then I actually want 3 test cases in this situation, or at least not 3 test cases, but I want to work through 3 different examples. I think that will be helpful. And I'm going to order them like this. All right, let's work through this. So I have the situation where the index is right in the beginning. I have a situation where the index is in the middle, and I have a situation where the index is at the end. So if I work these 3 cases out, I think that I will be good. The index is 0 or 1 or 2, and the size of the signal is always 3. And the indices are always 0, 1, and 2. All right, we can do this. Let's figure this out. We are pulling the data from the data structures that much. There isn't a lot going on there. Then I check if my index, so let's see, this first copy is from stuff that has been wrapped around. So for instance, these elements or this element, this element. So let's work this out. When do I want to do this copy and when do I not want to do this copy? I don't want to do this copy when I'm in this position where the index is exactly 1 fewer than the signal size. In other words, if I do want to do that, it is because, for instance, in this case, 3 minus 1, 3 minus 1, is greater than the index, so the index here being 2, I will not do this. But if it's 1 or 0, I will do this. And now let's see what chunk of memory we want to copy. I want to copy from array to array data because this is actually the destination. Yes, right. It's the destination and then the source and then the length. So the destination of this copy is going to be the array data at position 0. I always put this stuff in the beginning. Then the source is going to be the signal data plus the index. So in this case, it's not even going to happen. So let's reason about this case. The index is position 1. So I'm going to start at position plus index plus 1, which is the next one after that, which is position 2, and that's perfect. And then for the length, it's the signal size, which in this case is 3 minus 1, so 2, minus the index, which is 1. So 2 minus 1, 1. And the length is 1. That is correct. Now let's reason about this case for a moment. Array data at 0, that's easy. Signal data plus index plus 1. So we are going to start from position 1 because the index is 0. And then let's see for length, it should be 2. We want to copy 2 elements. Let's see if this works out. Signal size minus 1 is 2, minus 0 is 2. So that works out. Perfect. Now let's work through the indices for this one. I want to copy to the array at, I want to say position index plus 1. That's what my intuition is saying, but let me double check. So for instance, in this case here, I have already copied the 109 and I want to copy from position 1 onwards. So it is index. And in this situation, I want to copy from position 2 onwards. So that's actually not correct because in this case, I don't want to copy to position 0. So maybe it is more something like this. Oh, isn't this cute? Look at this formula. It's index plus 1 and this is minus index minus 1. That's cute. Okay, let's work this out and see if this is the case. So I want this position to be, in this case, I'm going to call this the magic position, the one that I'm working on right now. So in this case, I want the magic position to be what? This is the position in the destination. So in this case, I want this magic position to be 0. Because I want to copy the whole thing. What is the magic position in these two other cases? In this case, the magic position is, I already copied this 109, so the magic position is 1. And in this case, I already copied 111 and 112, so the magic position is 2. That's the magic position. 0, 1, and 2. Let's check this. Maybe I have the right formula already. So let's see. This is the formula that I currently have for the magic position. It reads like signal size, which is 3, minus 1, 2, minus the index. Let's work through this case first. So it's always 2 minus the index. So 2 minus the index is 0, 2 minus the index is 1, and 2 minus the index is 2. That is the correct formula for the magic position. Great. Boy, this is such like a simple function. It's like it's actually 2 lines that are interesting. But they're, for me at least, freaking complicated to reason about. I don't know for you, maybe you're like, oh man, it's just a bunch of indices. Of course, it's signal size minus 1 minus index, blah. But for me, this is like excruciatingly hard. Okay, moving on. So what is now this other thing? This is the source, where I want to copy from. I want to copy from the signal data, and I want to do that from what position? From position 0, always. That's easy. And how much do I want to copy? I want to copy index plus 1, don't I? Check this out. The index plus 1 is 1 element, the index plus 1 is 2 elements, and the index plus 2 is 3 elements, the whole array. And that's how we do it. I think that this is correct, so I'm going to get this code more ready for committing. I'm going to put this in a temporary buffer in case we need it. And I think I have my formula, and I am tempted to, so this does not occur again, but this occurs twice. I'm tempted to extract this to a variable. You know what? I'm not going to. And then we have our tests, and the test should be passing right now, if I did everything correctly. And I was very careful, so I am confident that this will pass the first try. Are you confident that this is gonna pass first try? I am. Yes, it passed. Let me prove it to you that the tests are really passing. I'm gonna change this value real quick. And then it's not passing. All right, so I think I did what I promised. In the video description, I said that I was going to do some data structure conversion, and this was super hard for me, but I did it. Data structure conversion. Here it is. Awesome stuff. I sure hope that this is right and it's not corrupting memory, because if it is corrupting memory, then it will be difficult to track these bugs down. All right. So now that we have this function, let us return to the line graph situation. And I have a delay lines stuff going on. And I don't need, so that's kind of interesting. Let's check this out. In the Where is it? Where is it? Delay line. What is delay line, ladies and gentlemen? Why do I have a single delay line on the GFX block but multiple in the sample block? And that looks wrong to me. It seems like I forgot to do something and the variable just happened to work out. I think that this is exactly what's happening, because the delay line variable is just something that is in this loop, and then it happens to be a global variable, so it's picked up in here in the GFX block, but that is incorrect. We should be doing delay lines at 0, for instance. Hello, yeah, this is more correct. But I was gonna say that even though we need multiple delay lines to store all the samples, because we actually have a delay effect going on, so we want to store multiple delay lines for all the different channels, but oh, so that's already an issue, right? I said that the delay lines were rather small, they are only a second, so they don't cross boundaries, but that's not true because we have multiple delay lines. So the delay line for the right channel is going to cross potentially one of the boundaries that we should not be crossing. So I think that there will be a bug there already. But let me get to my point. Even though we have multiple delay lines, one per channel, when drawing this on the screen, we can either just draw one of them like we are right now, just drawing one of them. But even if you wanted to loop and draw all of them, which is a reasonable thing for us to do, we may want to draw one per line or maybe on top of one another, something like that. So I think I would rather draw them one on top of the other, like you would see on the REAPER tracker here. But I don't need to have multiple arrays, even though the graphs line situation is going to use arrays. I don't have to have multiple of them. I can just keep reusing the same and I will keep copying the different delay lines into the array, which is a fun story. So let me find my delay lines. And I will have a delay lines array, which is going to be some new chunk of, not memory, some new array of the number of channels. Not quite, it will be this size. And then we can go to here. Let me split the screen because I'm gonna need to have a bunch of things on the screen at the same time. I'm gonna need to have these variable names. So I already have the delay lines situation, and I have this other variable name. And then I need to have this on the screen because I need my function to be on the screen so that I can copy and paste it. And there you have it. This is what we need to copy one of the delay lines into the delay lines array. And then what we are going to plot is this delay lines array. But of course, that's not going to work because the function that is actually plotting the thing is expecting some circular buffer. First of all, I want to change this variable name. It is going to be called array now. Does that make sense? I think it does. So I'm going to plot the array in this position, and then to get stuff out of the array, I'm going to change this into array, and then data size is going to become array.size, and data point width is going to be, I'm gonna call this just point width, or I don't know. Item, I think I'm gonna call it item. The array has some items. Item width. And this is wrapping to the next line. Let me fix this real quick. Perfect. So we have an array size, we have an item width, then we have height. I'm not going to think about this too much right now. The algorithm itself, I'm just going to rename some variables to make myself comfortable reading the code. Then we have some indices and blah, blah, blah. Okay. Let me focus on changing this from circular buffer into array. So we have the size of the array. We probably are going to need the data as well. So I'll just have another variable here for the data. That's what I'm calling it, right? Right. And then this is just arithmetic for computing the position. Then we have all the places where we're using the data. So this is going to be the array data at 0. And this is going to be the array data at index. And I really like that you do have to have this preamble, but then from then on, you can just pretend that this is an actual object. Coming back to my whole discussion about pseudo objects versus real objects, the usability of real objects, it's a trade-off. In some aspects, it is better. In some aspects, it's worse. And one of the worst parts of real objects is this. The good part of real objects is this, that you can loop over things. But the bad part is that you do have to get the data back out, so it's not super idiomatic. But once you have this preamble, then you can sort of pretend that you're using pseudo objects, which is great. So now I think I adapted this correctly, and I think we should be able to see this line graph, the oscilloscope working. Let's see. Hello, Oh, it's not working. It's all zeros. Let's commit what we have and start a good old debugging session here. And I'm going to pay attention to what I changed, because maybe I made a mistake that is easy to spot. Yeah, nothing is easy to spot from here, I don't think. Yeah. So we'll have to work through this more slowly. Did I make a mistake on this part? I don't think so, because it is just... Yeah, that was already there before. Then this item width situation. You know what? Maybe we can come here into this edit section and we can start poking using this thing here on the right. Yeah, let's do that. I'm so unhappy. I thought that I did everything correctly. Let me just remove everything and try again. Maybe that will be it. Hello? No. Oh, damn it. Okay. How about we check that the copying of the circular buffer is coming out all right. To do that, we can just drop a good old debug variable here, checking into the delay lines array under the array struct data in position 0, and that should be a sample, so it should be oscillating between -1 and 1. Let's do a good old full compile reset, move to the circular buffer page and look at the debug variable. So the debug variable seems to be all right between -1 and 1. Perfect. So copying the circular buffer seems to be all right, and the CPU is all right. So that makes me happy, even though we are doing a bunch of copying. Though I don't think that the CPU number corresponds to the GFX block. I think it's only for the audio processing part of it. But in any case, so we can remove this debug variable. The issue is not in the copying of the circular buffer into an array. So we need to dive into the graphs line function. Do we have the correct size? I will drop a debug size variable. And then remove, re-add, change to the right page, and go into edit and look for debug size. Yeah, the debug size seems okay. And then let's just take a peek at the data in position 0. That should be a sample, so it should be oscillating between -1 and 1. And it is oscillating between -1 and 1, so that much is all right. Then we compute this width, seems all right. The item width, that is also okay. Then we have height half. And then we have height midpoint. Then line X and line Y. Oh, I think that the indices in this array may be incorrect. Let's see. Or in this loop, the indices in this loop may be wrong. Let's see. It's starting from 0 because we have already plotted position 0. That is okay. And it's looping to array size -1 times. That is also correct. and we are +1 the index. That is all right, okay. Then we are finding the next one by subtracting the width. Oh, because we are going from right to left. That is the issue. We are plotting this from right to left. I forget why we are doing that, but we are doing that. I don't think there is a good reason for us to do this way anymore. So I'm going to go from left to right, which makes more sense conceptually anyway. So this x is going to start at x, and the y is going to be the first position, and then the index is going to go from 1 to size -1. And then the next x is going to be plus, and this is going to be the height midpoint minus the data in that position times half of that. That is perfect. And then everything else is going to work out. Okay, I think that the issue was that we were going from right to left before. Now we are going from left to right, and it's still not working, and it is drawing that weird curve, so we didn't fix everything. Oh, I think I know why this line is here. We are forgetting to multiply by half of the height. So we need to do this whole formula there. All right, let's see. Okay, that weird line is gone. That's good news. But what's up with the rest? Why is the rest not working? You know what? This index variable, it's not a big deal, okay? But this index variable is just kind of floating there. So I instead will have an array index variable. And I know that by refactoring this, I'm not getting anything, but I'm maybe breaking something, but whatever. It makes me happier. There you go. So let's see. I know that I am drawing a straight line, so I am going somewhere with this, right? This much is working. It is going somewhere. Let's double check this thickness thing, though it shouldn't matter. Oh, it does matter. Because did we remember to update this? Yes, it was working before in the beginning of this stream, so that's not the issue. Let's review this thickness situation here. We are looping for thickness times, and we are going from that to that. Everything in here seems all right for me. But yet, we don't see anything anymore. Let's check this array data going here. It should be samples. It should be numbers between -1 and 1. And it is numbers between -1 and 1. Okay. Then let's have a debug 2 going on. And let's check this. And this should be numbers like between 0 and 200 because they are like the positions where I should be drawing stuff. And this is always 300. That doesn't seem right. Oh, I forgot to rename this variable. And that was 0. See, renaming variables as you read code is always introducing bugs. Don't do that, people. Don't do that. Learn from my mistakes. And then there you have it. So this is looking good. It's not stuttering, so it seems like the copying of the memory really is quick. And you know what? As a grand finale, I will do a loop and I will plot all of these guys, all of the channels. How about that for fun? So I'll do a channel from -1 looping over the number of channels, channel plus equals 1. And this is going to be the delay lines at channel. And this is going to be, I still go from the same place to the same place. And I don't think I want to have that. So right now I have kind of a padding on the left and right. I'm going to remove that padding. But this is like the height, so... Oh, this is the width. I'm not going to touch that. And this is the height. The only thing I have to touch is this, which needs to be 400 times channel. Because the height of my display is actually 300. So the height of my display, given the paddings, is 300. So this is going to plot the different channels, one above the other. Perfect. Let's see. Remove that. Plop that in there. And let's do this. And it's not doing it. X, Y. Is it doing, but is it like cutting off? Yes, it is doing it. Oh, and it's affecting the audio and everything. Wow, that's amazing. What the hell happened? Okay, giving this another try. You can see some spikes in there. That is bad news. And when I increase this so that you can see the other one, it's flickering. And there are some spikes, so that's no good. And it's messing with the audio. You know what that means? You know what this means? This means that there is some corruption of memory somewhere. We are using memory in a way that is not safe. We are going over some array boundary or something. So there is a bug somewhere. But let's commit what we have, call it a day. And tomorrow on this channel, I will be doing some music production stuff. We'll be mixing a song, probably the drums. And then on Thursday, I'll be back here and I will be working on this. And I don't know exactly what I'm going to be working on. Maybe I will have figured out this memory corruption thing, because there is nothing really interesting about the process of finding memory corruption. It is just adding more tests for all the methods and commenting things out, all the things that we have already done in the stream. It's just me doing that for a long while. So maybe I will do it off stream. I don't know. But this idea of copying to array, I mean, it's the newest thing on the code, and it's probably where the bug is. Or maybe the issue is the memory alignment, because the result of copying the memory is undefined, and the issue started exactly when I put the second channel, which crosses the boundary. So there you have it. That's probably the issue. All right, fun stuff. So maybe my code is correct, and it's just the memory alignment that is missing. All righty. Okay. Let me commit what I have. I committed. So thank you all for being here, for watching this, for supporting me on PayPal and Patreon, for subscribing to the channel, for being on the chat. You are great. And I see you back here tomorrow for more Reaper stuff. We will be doing the mixing. And on Thursday, I will probably work on memory alignment, because everything was working and we started seeing the spikes and everything just fell on its face when we added the second channel, and the second channel is crossing the memory boundary, and that is going to freak out the memcopy function. So I think I already nailed what the issue is. It's mostly a matter of fixing it. So yeah, that's it. See you tomorrow. Bye.